record this. What that means is every sample of size n has the same chance of being chosen. All right, so in other words, if I have this population right here, the odds of me pulling out this sample of size n is the exact same thing as pulling out this sample of size n, this sample of size n, and so on. So again, it's not the fact that everybody has the same chance of being chosen, but it's that every sample of size n has the same chance of being chosen. Okay? So that's what makes a random sample a simple random sample. We're really talking about that sample of size n having the same chance being chosen across the entire population. So thinking about that, let's do this. Here is a table of random digits right there. And let's say that we have, well, let's do it easy first of all. Let's say we have 10 students in the class. Right. If we want to make a simple random sample of size 10, right, since we have 10 people, everybody could get their own individual number, right? So student 1 could get the number 1, student 2 could get the number 2, student 3 can get the number 3, and student 10, since we haven't used it yet, let's give them number 0. Right? And then what you want to do to construct your simple random sample is you want to pick a line at random. All right, so in this case, let's pick this line, line 6, line 106 there. Right? And then if we go along and read through these numbers, let's see. If I want to pull out, let's say, a sample of size 4, just go through here and see, since we gave everybody individual numbers, let's pull out the first individual number, and that's a 6, so that'd be student 6. Right? The second one is a number 8, so that would be student 8. Right? And then that represents student 4, and that represents student 1. Right? So that would be my sample of size 4 for this particular simple random sample. Okay? All right, now again, that's an easy one, right? Where if we have 10 people, give them all just individual digits and move on. Right? What if we don't have something that's quite as nice and neat as that one, right? So let's assume that we have, how about 12 students? Right. Well, since we have more than 10 people now, we can't give single digits. So the next option would be going to double digits. Right? And if you remember, for double digits, I've got 10 choices for the first digit, 10 choices for the second. So if you multiply those together, that gives me 100 double digit numbers. Right? And they go from 0, 0 up to 99. Right? So what we need to do in order for this to be a fair sample is we want to make sure that each person gets the same number of digits, right, or same number of values. Right? So since we have double digits, there's a pretty easy way we could do it just like we did last time. Student 1 could get 0, 1, student 2 could get 0, 2, 0, 3, and all the way down to student 12 could get the double digit 12. Right? But there's a problem with this, and let's pick another number line at random. How about line 105, right, where we're given these numbers. Right? So since we gave everybody double digits, let's pull out 2 digits at a time. Right? Of course, 95 represents no one, right? Because we're just using 0, 1 to 0. I'm sorry, 0, 1 to 12. 59, that's nobody. 29 is nobody. 40 is nobody. And oh, hey, finally, we picked someone. Right? That's student 7. So there's nobody, 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 and it keeps on going. Right? So this particular method, if you remember, was not efficient because we have 100 double-digit numbers. I'm using 12 out of the 100 double-digit numbers, which means I'm not using 88 out of the 100 double-digit numbers. Right? So that's the percentage waste that we have. right? So it's not very efficient at all, because 88% of the time we're going to get a double-digit number we can't use. Okay? So the way we got around this was, instead of giving everybody one double-digit number, well, we could give them two double-digit numbers or maybe three double-digit numbers. If you remember, the most efficient way we found this was to kind of just divide it all out, right? So I guess the question here is, how many values, right, does each person get? Right. Well, we have 100 values. Let's divide that by our number of students. Right, so I'll divide that by 12, and that gives me like 8.333 or something. Kind of goes on and on. Right. So if you remember our technique from what we did before, again, we can't give everybody 8.3 numbers. Right. So what we wound up doing is, at this point, we would round this down. Right. Because if I give everybody 9 numbers, that's too much, right? Because 12 times 9 is 108, and there aren't 108 double-digit numbers. Right? But 12 times 8 gives me 96 double-digit numbers, which I can work with. Right? So what we would do is, at least for our process, we would start student 1 and give them 8 double-digit numbers. So we would start at 0, 1 and then go up to 0, 8. Then for student 2, we'd give them 8 numbers. So that would give me 0, 9 to 16. And then student 3 would give me 17 to 24, and so on. And again, if you notice all these things, all I'm doing is I am adding 8 to this to give me 9 to 16, added 8 to those to give me 17 to 24, and so on. Right? So if we get down here to student 12, what are their numbers going to be? Right? Well, if you notice, student 1 ended at 8, student 2 ended at 16, student 3 ended at 24. Right? So that's just 1 times 8, or 2 times 8, or 3 times 8, which is just their student number times 8. So for student 12, 12 times 8 is 96, and that's where it's going to end. Right? And then if you notice, to backtrack and get that first number, you always just subtract 7 from there, because we've given them one number, so we need to give them 7 more. So if I subtract 7 from there, that gives me 89. Right? And then I can work backwards just by subtracting 8 from these things. That would be 81 to 88. And then this would be, 73 to 80, and so on. Right? So that's how I could set up those particular numbers. Okay? So now, if we use line 105, again, let me write these things down. I've got 95, 59, 29, 40, 07, 69, 97, so on. Right. So if we pull out this first number, if we have everything written out, we can see pretty easy that's supposed to be student 12. Right. But if we have, 100 people in our sample, we don't want to write out all those different numbers. Okay. So here's how we found out who to pick. We took the number that we had, right? So we took the value, and we divided that number by the number of values we gave each person. So in this case, I'm going to take 95, and I gave everybody 8 numbers, so I'll divide that by 8. Right? And then 95 divided by 8 is 11.875. Right? And for this one, if it divides out evenly, that's who you use. Right? Otherwise, you round this up. Right? So this represents student 12. Right? And then if you go to 59, 59 divided by 8 is, 7.375. So if I round that up, that would be student 8. Right? 29 divided by 8 is 3.675, so that represents student 4. 40 divided by 8 is 5. That divides out evenly, so I'll use student 5. Right? So there would be my sample of size 4. Okay. All right, so that's how you find a simple random sample in a nutshell. Right? You kind of write down your entire population there, right? or you come up with a little scheme like this to figure out what numbers each person's going to get. Right? Now, just as a quick reminder, in order for this process we used right here to work out, you have to start off at the number 0, 1. Right? So this number right here had to be 0, 1. Right? If you start off at 0, 0 or something else, then the rounding errors could be forcing you to get someone you don't mean. Okay, so remind yourself to always start off here at 0, 1 when you start assigning these values. Okay. All right. So any questions on just that quick reminder on a simple random sample? Okay. All right. Then if we look at the test, and the reason I did that one first is kind of it's used in a lot of these different ones, just kind of in the background. Let's talk about the systematic sample. All right. And the idea behind a systematic sample is this. Let me actually add a picture in here. Let's see. How about this one? Let's say that we have 24 students, right? And we want to create a systematic sample of size 4. Right? So what we're going to do is create 4 different columns. Right? And in this case, if I do that, then we'll put these people in here. Like I've got Angie, Amy, Casey, Laura, and then just kind of go in and fill in the rest of these. You can go downwards if you want to as well. It doesn't really matter, just as long as you put them in here somehow. Right. So then eventually this last row would be Becky, Crystal, Brian, and Tracy. Right. So what we do is we put, if I want a sample of size 4, I put 4 columns out there, and I fill in the 4 columns with the people in our population. Right. And then what we're going to have here is, in this case, I'm going to have 6 rows. Right? Because the 6 times 4 gives me 24. Okay. So we'll have 6 rows of people. 1, 2, 3, 4, 5. Yeah, 6 rows of people like that. Right. So for the systematic sample, once we have this framework set up, we pick a row at random. Right. So in this case, that's just going to be a simple random sample of size 1. You know what can you all see that? Size 1 from a population of 6. All right, let's see. Hang on a second. Okay. So we have row 1, row 2, row 3, row 4, row 5, and row 6. So just pick one of these at random. Right? Just do a simple random sample on those 6 items. Right? You could use single digits here, double digits, whatnot, but whichever one you happen to pick, let's say we pick row 4. What I would do is I would take 1, 2, 3, I would take everybody in row 4 as my sample. Right? So that would be my systematic sample. Right? So that's where you set up the framework, right? Pick your row at random, and then use that entire row. Okay. So let's look back at the test real quick. In the test, it says we have 235 employees, and we have 158 females, 77 males. Right? And what we want to do is to create a couple of samples. Right? All right, so for the first one, we have a systematic sample of size 5. Which means what I will do is I will make a framework with 5 different columns. Right? And let's see, 235 divided by 5 is 47. which means I will have 47 rows. So what I can do is I can put employee 1 here, maybe employee 2 there, employee 3 here, go all the way down to where this would then be employee 47. Go back up top, make that employee 48, whoops, employee 49, employee 50, and then down here, if you add 47 to 47, you get 94. Right? So if I have 47 rows, to get to the next person, I'm just going to add 47 to this. So this would be employee 95. If I add 47 to this, that's 130, that'd be employee 142, and that would be employee 189. And then down here, let's see, if I add 47 to that, gives me 141, 188, and if I add 47 to that, gives me 220, 235. Right? So that's all 235 people. Right? So if I'm here, and this is, let's say, employee number K, then this would just be K plus 47, right? Because I have 47 rows. Right? And then this would be that number plus another 47, so it'd be K plus 94, and then add another 47 and so on. Okay. All right, so for the systematic sample, what I'm going to do is let's pick one of these rows at random, right? So let's take employee 1, employee 2 down to employee 47. Let's make a simple random sample here and see which row to use. Okay. All right, so for this one, if I make a simple random sample, if we give everybody 2 digits, right, that's 2 times 47 is 94, right? Or if you take 100 double-digit numbers and divide that by 47, you get something like 2.0 something, right, which tells me to use 2 digits. Right? Employee 1, remember how we want to start this. Let's let them start at 0, 1 and go to 0, 2. And then since we're giving everybody 2 numbers, just add 2 to all of these. Right? And then eventually here, this last one, if we multiply it by 2, we get 94. So it'd be 93 to 94. Okay. And then in the problem, it gives us these numbers to use from line 3. It says use 7, 7, 7, 9, 3, 1, 1, 8, 4, 3, 0, 0, 0, 5, 7. Okay. All right. So let's pull these out. Well, in this case, I really just need to find one. If we look at 77, right, remember how we find who it represents? We take that value and we gave everybody 2 numbers, right? Give everybody 2 numbers, so I'll divide that by 2, and that gives me 38.5, which rounds up to person 39, right? So I'll use person 39 right here and their entire row. So the next person, if we add 47 to that, gives me 86. So that would be person 86. If I add 47 to that, gives me 133. If I add 47 to that, gives me 180. And if I add 47 to that, I get 227. So these people would be my systematic design, right? So it's employee 39, 86, 133, 180, and 227. So that would be the sample we would pick for this particular problem. Okay. All right, so again, that's a systematic sample. You set up your framework, then you pull out one person on this simple random sample, and then whatever person you pull out, you use that entire row as your sample. All right, any questions or concerns about that systematic example before we move on to the next style? Okie dokie. Well, the next style of sample in this exam or in this test was a stratified sample. And the idea for a stratified sample is you take your population and you break them up into different non-overlapping groups, right? And each of these groups are called strata. Okay. And then what we're going to do is we'll pull out a simple random sample from each strata and then join them together into one big sample for our overall total. Okay. So that's a stratified sample. So let's see what this problem is asking us to do here. All right. So in this case, we're still in the previous setting, right, to where we have 235 employees. 235 employees, right, of which we have 158 females and 77 males. Okay. All right. So what we're going to try to do is, in this population, we're going to break them up into these two stratas, females and males. Right? And in this case, I'm going to try to pull out a sample of size 6 from the population. Okay. Now we want the sample to represent the entire population. So let's see how many people do we want to pull from each of these strata. Like for instance, I don't want to pull out 3 females and 3 males, right? Because that would be 50% females and 50% males in the sample, which doesn't match up to what's going on with the population, right? So for the population, let me give you that particular number. We have 67% females and about 33% males, right? So about twice as many females as we do males. So that means in this sample, I want 67% to be females and I want 33% to be males in the sample, right? So for females, I want 67% of my sample size 6, which is 0.67 times 6, which gives me 4.02, which rounds to 4 people, right? And then for the males, I want 33% of 6, which is 0.33 times 6, which is 1.98, so that rounds to 2. Right? And then if you notice, if we set it like this, I have twice as many females as I do males, which represents the population. Okay, so for this stratified sample, what I'm going to do is I will pick a sample of size 4 from here, a sample of size 2 from here, and then join them together into this one big sample. Okay. So what I will do is, for the females, I will pull out a simple random sample of size 4. For the males, pull out a simple random sample of size 2, and then put the 4 females in here, the 2 males, and that's going to be our group. Okay. All right, so that's the idea, and I'll do one of these things, I'll let you all do the other. Let's say for the females, we have 158 females. So what we would do is, I would just line them up from 1 to 2 to 3 all the way down to 158. And I would give them some numbers here. I can't use single digits, can't use double digits, so I have to go to triple digits. So there are 1,000 triple digit numbers, right? And 1,000 divided by 158 gives me 6.32. Over 158 is 6.32, which means I'll give everybody 6 digits. Right? So this person gets 01 to 06. This person gets 07 to 12. They get 13 to 18. And then this last one, let's see, 158 times 6, 8, carry the 4, 3, 948. And I already gave them 1, so if I subtract off the other 5, gives me 943. Right? So there's our setup for the females in terms of picking their part of the strata. Right? In the problem, we are said to use these digits for the females. Let's see, 028, 582, 510, 732. So let's pull them out 3 digits at a time, since I gave everybody 3 digits. So 342, I gave everybody 6 numbers. Right? So if you divide that out, you get 57. So that one divides out evenly. Right? So the first person I'll pull out here is employee 57. The next triple digit number is 975, which if you notice doesn't represent everybody, so that person's out. Right, so this could be female 57. 028, well, 28 divided by 6 is 4.333, right? So if we round that up, that would be female 5. Whoops, right here, female 5. 582, let's see, 582 divided by 6 gives me 97. That divides out evenly. So this is female 97. So I need one more. The next triple digit number is 510. Divide that by 6. Divides out evenly to 85. Right? So in my sample over here at the end, I would put in there, I guess, female 57, 5, 97, and 85. Right? And then I would go over to the male group and pull out a sample of size 2 from those 77 males. Okay. All right, so that's a stratified sample. That's the idea where you take your entire population, break them up into these subgroups called strata, and then within each strata, find your sample using a simple random sample, combine them together here at the end for your big sample from the population. Okay. All right, any questions on that stratified sample? No. Okay. Let me see what else I wanted to see here, because I had some pictures. Ooh, here you go. Yeah. So again, this picture kind of represents a stratified sample, right? So here I have these two strata. I have this strata, right? So there's strata 1, and oh, I take that back, right? In this case, let me undo that. We actually have 3 strata. We have a red strata, strata 1. We have a green strata, strata 2, and a blue strata, strata 3. And what we want is we want to pull out 2 people from strata 1, and then 1 person from strata 2, and 1 person from strata 3. Right? All right, so you can see what happened here is they picked, of these red people, they picked 2 of them at random to put in there. And then of the green people, they picked 1 at random to put in the stratified sample. And then from the blue one, we picked this one to be in that sample. Right? So we joined all of these together to form that big sample. Okay. All right. One more type of plot that's on this, and there's some histograms and things, but we'll do those on the next test as well, so I'll kind of leave that for now. But it's called a stem and leaf plot. Right. And let me give you a data set here. Okay. So for this particular type of plot, if you remember, the idea is to pull off the last digit. Right? These are called leaves. Right? And then everything else that's remaining are called the stems. Right? So if you look at our data set that we've got right here, right? If we think about what the stems could be, it looks like most of these things are double digits. So for instance, this 7 right here, let's think of that as 0.7, and that number 5 could be 0.5. That way everything has the same number of digits. All right? And then if we peel off that rightmost digit, it looks like we have everything from a 0, right, to a 1, a 2, a 3. And what you want to do is put in every one of these stems that you can find. Okay. So then for our leaves, right, we'll go through here just one at a time. Look at this first score, 17. Go to where the stem is 1, put a leaf of 7. For this 23, go to the stem of 2, and you get a leaf of 3. and then you get a 46, and then a 31, a 17, 19, 26, 31, 42, 0, 5, and then I'm going to fill these in as quick as I can. 21, 32, 36, 7, 7, 8, 41, 40, 19, 12, 0, 7, 48, 29, 39, 42, 38, 41, 32, 36, and 35. Barely squeezed it in there. Okay. So for this one, once we have this drawn out, if you're not using a leaf like these ones right here, you can get rid of them. But the one thing you have to be careful of, let me add a couple of numbers down here. Let me say, how about 67 and 72? So 5, 6, and 7. I would have a 67 and a 72. If you have a gap in there like this, you want to leave that in there. But if you had some extra numbers down here at the end that you don't use, if you don't use those at all, then you can take those and cut them out if you're not using them. Right. But if you just happen to have a gap in the middle of your data set, make sure you leave that particular gap in there. But if you have some extras down here at the end, or even on the other end up here, you don't need to write those down. Okay. So that's a stem and leaf plot. Right. So on our test, we had this particular problem set. We had the numbers 793.8, 793.1, 792.4, 794.0, 791.4, 792.4, and 794.4. Right. So if we peel off all those last digits, what's left over? Looks like the smallest number is a 791, and then the biggest number is 794. Like this. Okay. In which case I could have a 793.8, 793.1, 792.4, 794.0, 791.4, 792.4, and then 794.4. Okay. And when you draw these things out, try to make it to where all of the first entries line up like this, all the second entries line up, all the third entries line up. Right? This way it makes it look easier to read. And also make sure that you order the leaves when you get done. Right? So this one really should look like, if I erase this, this should look like 0.0, 0.4, 0.4. Right? This one would look like 0.1, 0.8, and the other two rows are already done. Okay, so that's what your stem and leaf plot would look like. All right, so any questions on our stem and leaf plot? Excellent. Let me do one more thing for you, and that's just to remind you how to find, standard deviations and variances. This was also on that test. So let me add a picture in here. How about this table of random digits real quick? Okay. Let's pull out just single digits. Let's pull out a sample of size 9. Okay. So if I looked at line 103, I'm going to pull out the numbers 4, 5, 4, 6, 7, 7, 1, 7, and 0. All right. Let's try to remind ourselves how to find the standard deviation here. Okay. All right. So let me do something real quick. Copy this. If I can cut that. Ooh, awesome. And then let me take this thing up here. Okay, so let's find the standard deviation for this particular data set. Okay. If you remember what the standard deviation measures, right, it measures spread around the mean. So the first thing we have to do is find the mean from this data set. Right? So if we add all of this stuff up, right, we'll get a 4 plus a 5 plus a 4 plus a 6 plus a 7, 7, 1, 7, and 0. And that'll add up to be a 41 over 9. Right? And if I divide that by 9, I get this. So let me do this just because I'm kind of a sissy. I'm going to take that 4 out and replace it with a 0. Because if I do that, then that adds up to a 36. And 36 divided by 9 is 4. All right, just so we can get through this kind of quickly. So to find the standard deviation, we're trying to measure the spread around the mean. So what we're going to do is, first of all, figure out how far everything is from the mean. So if I write down all of these numbers from our data set, to see how far they are from the mean, let's just subtract the mean from all of them. Right? So 4 minus 4 is 0, 5 minus 4 is 1, I get a negative 4, a 2, a 3, a 3, a minus 3, a 3, and a minus 4. And if we found it right, this column should sum to 0. Right? So if you add them up, you get 1 plus 4 is minus 3, minus 1, positive 2, positive 5. Did I do that right? Negative 3, negative 1, 2, 5. That gives me a 2. Let's see. 9, 15, 16. Oh, I'm sorry. I really can't add. That should be a 1, which would make this a minus 3. And yeah, and then that adds up to 0. Okay. Now, if we try to average those numbers, it's always going to be 0. So what we wound up doing is we took all these values we just calculated and squared them to turn them all positive. Okay. And then if we if we square all these numbers, I'll get a 0, 1, 9, 4, 9, 9, 9, 9, 16. Right. So now we want to sum all these numbers together. Let me actually do this by calculator so I don't mess that up. So 10, 4, 9, 9, 9, 9, 16. That adds up to a 66. Right. So what we're going to do is we're going to take that 66 and divide it by n minus 1. So in this case, that's 66 over 9 minus 1, and 66 over 8 gives me 8.25. Right? And if you remember, this number is the variance. Variance. So to get the standard deviation, we just take the square root of the variance. Right? And the square root of 8.25 gives me 2.87. Okay. All right, so that's how you can find your sample mean and your sample standard deviation. Right? Of course, sometimes we're asked to find the range from a data set. Right? That's just the biggest value minus the smallest value. So in this case, that would just be 7 minus 0, which is 7. Okay. All right, so that's it. At least in terms of finding your standard deviation and your variance and everything else. So that should be able to get you through test 1, at least your review on that. So go through those problems, see if you have any questions, and I guess let me know. Right. So while we're here, are there any of those from the first test that y'all would like to ask about in particular? Anything I can try to clear up for you one time before you get out of here?